Good morning, students. I'm Sangeeta, lecturer in chemistry, branch general section, working in GPT Narankhed, semester 2, subject engineering chemistry and environmental studies, subject code 18C204F, major topic electromotive force, duration 30 minutes, subtopic nickel cadmium cell, teaching aids, PPT, diagrams, animations wherever required. So today's our topic is nickel cadmium cell. Recap. Let us recollect what we have discussed in last class. So what we have discussed in last class? In last class we discussed lead storage battery, its working and its applications. So once again I will revise this lead storage battery working and its applications. So it is a secondary battery. Okay, so what is meant by secondary battery? It is rechargeable and reused again. So how is the construction of lead storage battery? So like this. So anode and cathode are alternately arranged in an electrolytic solution. So which is anode here? Lead is anode and lead oxide is cathode. So these are lead plates and lead oxide plates are alternatively arranged in an 38% sulfuric acid solution. So this is acting as anode, this is acting as cathode. So what is the EMF of this cell? The EMF of this cell is 2 volts. So here we will see. So what are the reactions taking place at anode and cathode? So at anode, oxidation, at cathode, reduction. So this is the reaction taking place at anode. So lead is converting into lead sulfate. So by releasing 2 electrons, it is combining with SO4 minus 2 and forming lead sulfate. So this is the reaction taking place at anode. So at cathode, what is the reaction taking place? Lead oxide is converting into lead sulfate. So how it is converting? It is taking 2 electrons, it is reacting with sulfate ion, it is reacting with H plus ions and forming lead sulfate and 2 molecules of water. So this is the reaction at anode, this is the reaction at cathode. So this is the oxidation reaction, this is the reduction reaction. If you combine these two reactions, you'll get the overall reaction, that is the net reaction of the cell. So this Pb plus PbO2 plus here 2 sulfate ions and 4 H plus, that means 2 moles of H2SO4 is reacting. Okay, then you are getting 2 moles of PbSO4 and 2 moles of water. So this is the overall reaction. Okay, so these are the reactions taking place during the usage of the battery. So whereas during charging, what is happening? These reactions will be reversed. That means this PbSO4 is converting into Pb and PbO2. So overall reaction will be reversed. PbSO4 plus 2H2O gives rise to this Pb plus PbO2 plus 2H2SO4. Whereas at anode, PbSO4 plus 2 electrons gives rise to Pb plus SO4 minus 2. Similarly, PbSO4 plus 2H2O gives rise to PbO2 plus SO4 minus 2 plus 4H plus 2 electrons. So like this, you have to write the reactions during charging. So what are the applications where it is used? Used in automobiles and in inverters, used in electric motors in submarines, that is Jalantargamis. Okay. So this is the lead storage battery we discussed in the last class. So today we are going to discuss about nickel cadmium cell. So what are the objectives? On completion of this period, you would be able to understand working of nickel cadmium cell and applications of nickel cadmium cell. So this is also a secondary cell. So already one secondary cell we studied in the last class, that is, what is that? Lead storage battery. So today we are studying about nickel cadmium cell. Okay, so this is also a secondary cell, nickel cadmium cell. So here, this is a secondary battery consisting of cadmium anode and nickel oxide cathode. So this is also a secondary battery. So one secondary battery we studied in the last class, that is lead storage battery. So here anode is cadmium and cathode is nickel oxide. And KOH is used as electrolyte. So what is the electrolyte? Potassium hydroxide is the electrolyte. Then the following reactions take place during discharging. So whatever the reactions I am giving here, reactions during discharging only. So if at all in exam they will ask during charging, you have to reverse the reactions. Okay, so we will see the structure of nickel cadmium cell. So this is the structure of nickel cadmium cell. This is the electrolytic solution. This is the anode. Okay, this is the cathode. So here power conditioning system. Okay, charge discharging cadmium. Okay, this what are the products forming during the reaction. Okay, so this is the construction of nickel cadmium cell. Anode, cathode and electrolytic solution. Okay, so here at anode, you know which reaction? Oxidation. What is oxidation? Losing of electrons is called oxidation. So which is undergoing oxidation here? Cadmium. This cadmium is releasing electrons. So it is converting into CD plus 2. Okay. So then it is reacting with hydroxy ions. So here CD converting into plus 2 state. So that's why 2 hydroxy ions are required. So it is combining with 2 OH minus ions and forming CdOH taken twice, that is calcium hydroxide. So cadmium is converting into calcium hydroxide by undergoing oxidation. Okay, this is the reaction taking place at anode. So this is here oxidation state is 0. So here oxidation state is plus 2 OH, 1 OH minus 1, 2 OH minus 2. So oxidation state is plus 2. So this is the reaction at anode. Then at cathode, what is the reaction? Reduction. So which one is undergoing reduction? Nickel oxide. So nickel oxide is acting as cathode. So this nickel oxide only undergoing reduction. So nickel oxide is converting into nickel hydroxide. So it is taking electrons and it is reacting with water molecule and converting into nickel hydroxide, and 2 hydroxy ions are releasing. So here 1 nickel oxide is reacting with 2 moles of water and it is taking 2 electrons. So here if you see nickel oxide, what is the oxidation state of nickel oxide? So for 2 oxygens minus 4, so nickel plus 4 state. So as it is taking 2 electrons, it is converting into plus 2 nickel hydroxide. Okay, plus 2. So it is undergoing reduction. So losing of electrons is called oxidation and gaining of electrons is called reduction. So to form hydroxide, it needs H plus ions. So it is reacting with water and forming nickel hydroxide, and 2 hydroxy ions are released. So this is the reaction at anode, this is the reaction at cathode. You combine these two reactions, you will get the overall reaction, that is the net reaction of the cell. So see here net reaction, CD plus NiO2. See here CD plus NiO2. So here 2OH minus, 2OH minus cancels. So 2H2O. So electrons are cancelled. And what are the products? Cadmium hydroxide and nickel hydroxide. So that's why CD plus NiO2 plus 2H2O gives rise to CdOH taken twice, NiOH taken twice, plus electrical output, that is energy. So this is the overall reaction, cadmium nickel oxide plus 2 water molecules, cadmium hydroxide, nickel hydroxide. So what is the EMF of the nickel cadmium cell? The EMF of nickel cadmium cell is 1.4 volts. So this is very important. For dry cell, it is 1.5 volts. For lead storage cell, it is 2 volts. For nickel cadmium cell, it is 1.4 volts. Okay, then come to the applications. So where these cells are used. These are used in portable power tools, electronic devices, flashlights, cordless and wireless telephones, remote control toys, UPS, computers, etc. So these cells are used in many tools, okay? Portable power tools, electronic devices, flashlights, cordless and wireless telephones, remote control toys, UPS, computers, etc. So these are the applications of nickel cadmium cell. So okay, you understood nickel cadmium cell. So it is a secondary cell. Okay, this is rechargeable and used again and again. Here cadmium is anode and nickel oxide is cathode and KOH is electrolyte. And here whatever the reactions I have given, these reactions are taking place during discharging of this cell. So at anode, which reaction? Oxidation. So cadmium is undergoing oxidation. It is reacting with two OH minus ions and forming cadmium hydroxide. At cathode, what is the reaction? Reduction. So which is undergoing reduction? Nickel oxide. The nickel oxide is converting into nickel hydroxide. So it is reacting with water molecules and electrons and forming nickel hydroxide, and two hydroxy ions are formed. So here two hydroxy, here two hydroxy. These two are cancelled. Here two electrons, here two electrons. These two electrons are cancelled. And remaining overall reaction, how will you write? Left side, right side, right side. So cadmium plus nickel oxide plus 2H2O gives rise to CdOH taken twice, that is calcium, cadmium hydroxide, and NiOH taken twice, nickel hydroxide. So this is the overall reaction. And the EMF of the cell is 1.4 volts. Okay. Then next, come to the summary. So in this period, we have discussed these two topics: working of nickel cadmium cell and applications of nickel cadmium cell. So see here diagram, very simple: cathode, anode and electrolyte. Okay. So this is the transformer. Okay. So here products. So this green represents cadmium anode. Okay. Then here nickel hydroxide. This blue represents nickel hydroxide, and this one represents cadmium. Green one represents cadmium hydroxide. Okay, red color spots. Then OH minus ions, small red dots, and this water molecule. Okay. And come to the objective type questions. So what type of objective type questions you may expect from this topic? So first question, which of the following act as anode in nickel cadmium cell? So in this, which is acting as anode? So A cadmium, B magnesium, C zinc, D none of the above. So answer is cadmium. Cadmium is acting as anode in nickel cadmium cell. The next, the EMF of nickel cadmium cell: A 2 volts, B 1.5 volts, C 1.4 volts, D 1.2. So what is the answer? C. 1.5 is for dry cell, 2 volts for lead storage battery, and 1.4 for this cell, nickel cadmium cell. So the EMF of nickel cadmium cell is 1.4 volts. Okay. So then next question. And come to next question. The electrolyte in nickel cadmium cell is. So what is the electrolyte in nickel cadmium cell? So A sodium hydroxide, B potassium hydroxide, C ammonium hydroxide, D KCl. So what is the answer? D. So potassium hydroxide is acting as electrolyte in nickel cadmium cell. Okay, then come to questions and assignment. So, simple topic. So, explain the working of nickel cadmium cell and write the applications of nickel cadmium cell. Okay, so today we finished the nickel cadmium cell. So once again we will revise this primary cell and secondary cell. So in your syllabus you have one primary cell, two secondary cells. The primary cell is dry cell. It is very important. Compulsory one question you will get from this topic, this batteries. Okay, dry cell. It is a primary cell. Okay, so first, what is anode, what is cathode, what is the electrolyte, what is the EMF of the cell. This thing you have to remember. So a zinc container itself act as anode. Cathode is carbon rod surrounded by powdered manganese dioxide and carbon powder. And the electrolyte is moist paste of ammonium chloride and zinc chloride. So the EMF of the cell is 1.5 volts. So here at anode oxidation, at cathode reduction. This you have to remember always. So here zinc container itself acting as anode. So the zinc itself undergoes oxidation. So Zn gives rise to Zn plus 2 electrons. So at cathode which is undergoing reduction, manganese dioxide. So this is undergoing reduction by taking one electron and reacting with NH4 plus ions. So this NH4 plus ions, okay, this NH4 plus ions, what they are doing, they are this is subscript, okay. This NH4 plus is giving hydrogen to this one, so that it is converting into MnOOH, and as it is giving one hydrogen, it is converting into ammonia. As this gas is explosive in nature, this gas is trapped by the Zn plus 2 ions. So whatever the paste we are taking, no, Zn plus Cl2 and ammonium chloride. So this Zn plus 2 trapping this ammonia and converting into complex. So these are the reactions taking place in dry cell, and this is the construction for dry cell. This is the zinc container. Okay, so this is the anode. Okay, so this is covered by manganese dioxide and carbon powder, and this is the paste of ammonium chloride and zinc chloride. So anode always negative sign, cathode always positive sign. Okay, so this is the primary cell. So what is the EMF of this cell? 1.5 volts, where it is used in transistors, clocks, camera, hearing aids, radios, etc. Okay, this is the primary cell. This is the only primary cell you have in the syllabus. So examples for primary cell, dry cell and mercury cell, but mercury cell is not there in your syllabus. Then come to the secondary cell. So lead storage battery. This is the secondary cell. Okay, this is the first secondary cell you studied. So what is secondary cell? The cell which is rechargeable and reused again and again. So lead storage cell consists of lead plates, act as anode, and alternating with lead packed with lead oxide as cathode. So here lead oxide will act as cathode. And what is the electrolytic solution? 38% sulfuric acid solution. So these are the reactions taking place during discharging of the battery. Means that is during use of the battery. So lead is converting into lead sulfate. Okay. So Pb plus SO4 minus 2 reacting, and you are getting PbSO4 and 2 electrons are released. This is the reaction taking place at anode, that is oxidation. Which is undergoing oxidation? This Pb. It is in zero state, it is converting into plus 2 state. Okay. Then at cathode. PbO2 is converting into PbSO4. See here, Pb is converting into PbSO4 and PbO2 is also converting into PbSO4. So here this is undergoing oxidation, this is undergoing reduction. So PbO2 in which state? Marks Pb oxidation state is how much? Plus 4. Plus 4 to it is converting into plus 2. That means it is taking electrons. It is taking 2 electrons, it is combining with SO4 minus 2 and 4H plus ions are reacting and it is converting into PbSO4 and 2 water molecules. So this is the reaction at anode, this is the reaction at cathode. So if you combine these two reactions, you will get the net reaction. So Pb plus PbO2. So here 2 sulfate ions, 4H plus means 2 moles of sulfuric acid is reacting and you are getting 2 moles of PbSO4 and 2 moles of water. So electrons are cancelled. So this is the overall reaction of this cell. So whatever the reactions taking place, these are during discharging. While charging, these reactions will be reversed. That PbSO4 is converting into Pb and PbO2. So what is the EMF of this cell? 2 volts. Dry cell 1.5 volts. Lead storage battery 2 volts. Okay. So this is the construction of this battery. Okay. Lead oxide alternately arranged, and this is the 38% sulfuric acid solution. Okay. What are the applications? They are used in automobiles and inverters and used in electric motors and in submarines. Okay. So today's our topic is nickel cadmium cell. So this is also a secondary cell. That means it is also rechargeable and reused again and again. So here, which one is anode? Cadmium is anode. Nickel oxide is cathode and KOH is electrolyte. And the reactions. Cadmium is undergoing oxidation. Nickel oxide is undergoing reduction. So cadmium is converting into cadmium hydroxide. So it is reacting with OH hydroxy ions and converting into cadmium hydroxide and 2 electrons are released. So nickel oxide is undergoing reduction, taking 2 electrons and reacting with water molecule and converting into nickel hydroxide. Cadmium is converting into cadmium hydroxide, nickel oxide is converting into nickel hydroxide. And 2 hydroxy ions are released. So hydroxy ions cancels, 2 electrons cancel, so remaining. So you have to combine cadmium plus nickel oxide plus 2 water molecules gives rise to cadmium hydroxide plus nickel hydroxide. So this is the net reaction of the cell. Okay, cadmium plus nickel oxide plus 2 water molecules gives rise to cadmium hydroxide plus nickel hydroxide plus energy. So what is the EMF of the cell? 1.4 volts. Dry cell 1.5 volts. Lead storage battery 2 volts and nickel cadmium cell is 1.4 volts. Then come to applications where these cells are used in portable power tools, electronic devices, flashlights, cordless and wireless telephones, remote control toys, UPS, computers, etc. So this is about nickel cadmium cell. So one primary cell, that is dry cell, 2 secondary cells, that is lead storage battery and nickel cadmium cell. So in the next class we will study the fuel cell. So what is meant by fuel cell? So why I am repeating again and again, these are very important, and in C18 curriculum they included compulsory 2 cells you'll get in the exam, and these cells working, they will ask working of so and so cell, that is for 5 marks. Very important. Equations are very important. So if you write the equations correctly, you will get full marks. Okay, so dry cell, lead storage cell, nickel cadmium cell. Okay, if you have any doubts, we will clarify your doubts in the next class. So once again, what is a battery? group of galvanic cells designed to convert chemical energy into electrical energy or spontaneous redox reaction is called as battery. So batteries are how many types? Two types. It is primary battery and secondary battery. What is primary battery? So they become dead over a period of time and cannot be recharged and reused. So again are called primary batteries. So what are the examples for primary batteries? Tricell and mercury cell. Then secondary batteries, these are rechargeable and used again and again. So those batteries are called secondary batteries. Examples for secondary batteries, lead storage battery and nickel cadmium cell. Okay, so these are the batteries. Okay, then come to this unit. So in this unit, electromotive force. In the next class, we will finish this unit. That is the last topic, H2O2 fuel cell. So electromotive force. So first part we studied in the first semester. That is in first semester we studied electrolytic cell. So in the second semester, we are studying galvanic cell. So you have to differentiate what is electrolytic cell and what is galvanic cell. So what is electrolytic cell? So you should get this picture in your mind. So this is galvanic cell. Galvanic cells means two beakers. Okay, electrolytic cell means one beaker. So in one beaker, two rods. Okay. Here in two beakers, in two separate beakers, in one beaker we are dipping one rod and in another beaker we are dipping another rod. So that is the difference between electrolytic cell. So in electrolytic cell we are passing electricity from a external source like battery. So here this is the source of electricity. This galvanic cell itself is the source of electricity. So this is very, very important. So this is the construction of galvanic cell. So here one beaker we are taking zinc sulfate. In that we are dipping zinc rod. And in another beaker we are taking copper sulfate solution. In that we are dipping copper rod. And these two are connected by an voltmeter. And these two solutions are connected by inverted U-shaped tube called salt bridge. So why we are saying this as salt bridge? This tube is filled with salt mixture. It is KCl and KNO3. Okay. So this is the construction. And come to the working of this galvanic cell, how it works, how electricity is generated. So here spontaneous oxidation and reduction, that is redox reaction taking place. So due to that electricity is generated. So at anode oxidation, at cathode reduction, whatever may be the cell, whether it is electrolytic cell or galvanic cell, always at anode oxidation takes place, always at cathode reduction takes place. So here zinc acts as anode. So here oxidation takes place. This copper acts as cathode. Here reduction takes place. So this zinc undergoes oxidation. So here electrons are released and these electrons flow through this external circuit and move to the cathode. So near the cathode, Cu plus 2 ions are present. These Cu plus 2 ions are undergoing reduction and forming copper metal. Whatever the copper metal forming, that will be deposited on the cathode. So here already I told while telling this class, this equation is wrong. Zn gives rise to Zn plus 2 electrons. So already I have given the equations here. This is the working or functioning of the galvanic cell. Okay, Zn gives rise to Zn plus 2 electrons and Cu plus 2 electrons gives rise to Cu. This is the oxidation, this is the reduction. If you combine the reactions at anode and cathode, you'll get the net reaction, that is Zn plus Cu plus 2 gives rise to Zn plus 2 plus Cu. So here, if you see the diagram, this anode is given negative sign and this cathode is given positive sign. Whereas in electrolytic cell, anode is given positive sign and cathode is given negative sign. This is quite opposite. So Y means it is giving the electrons. That means it is rich of electrons. That's why it is given negative sign. Whereas it is taking the electrons. That means it is short of electrons. So that's why it is given positive sign. So this is about galvanic cell. So this is very, very important. Then you have differences. So if you see the diagram, so you get the differences easily. Okay, if you know the diagrams, if you keep the diagrams in your mind, you can easily write the differences. These differences are very, very important. So first, electrolytic cell, galvanic cell here converts electrical energy into chemical energy. So here we are passing electrical energy, that energy is converting into chemical energy. So here this cell undergoes spontaneous reduction and converts chemical energy into electrical energy. It requires source like battery, whereas it only acts as source of electricity. Here, just now I told cathode is represented by negative sign, anode by positive sign, whereas cathode is represented by positive sign and anode by negative sign. Salt bridge is absent, salt bridge is present. Two electrodes are present in same electrolyte, whereas two electrodes are present in separate electrolytes. Okay, one electrolyte is used, here two electrolytes are used. Here electron flows from anode to cathode, here electrons flows from cathode to anode. So next, what is the next topic we studied? That is standard electrode potential. So the electrode potential. So first of all, you should know the electrode potential. So what is the electrode potential? Electrode potential means the tendency to lose or gain electrons by an electrode is called electrode potential. If it is losing electrons, that is called as oxidation potential. If it is gaining electrons, that is called as reduction potential. So standard electrode potential means the potential of the electrode measured at 298 Kelvin and 1 m electrolyte concentration is called standard electrode potential. Or you can define another way, the electrode potential of a half cell when the concentration of electrolyte is unit, it is 1, is called standard electrode potential. So here we studied SHE. This is the standard hydrogen electrode or normal hydrogen electrode. So this is the beaker. In that beaker, this is electrolytic cell. That means we are taking HCl solution 1 m and we are dipping platinum wire coated with platinum black enclosed in glass tube. Okay, onto that we are passing hydrogen gas having 1 atmospheric pressure. So nothing but standard hydrogen electrode. The potential of this electrode is 0 volts and this electrode is taken as reference electrode to measure the potentials of other electrodes by constructing a galvanic cell. Okay. Electrochemical series. Series of metals arranged in the increasing order of their reduction potentials or decreasing order of their oxidation potentials is called electrochemical series. Okay, so electrochemical series, the electrode with more negative reduction potential is placed at the top and the electrode with more positive potential is placed at the bottom. If you see the series here, so topmost elements are active elements and bottommost elements are inactive elements. If you come to the significance of this series, the reactivity of the metals increases along the series and the reducing ability of metals decreases along the series. The metals with more negative potentials are strong reducing agents. So what is then happening? Reducing ability decreasing along the series. So whichever metal is having more negative reduction potential, they will act as strong reducing agents. Strong reducing agents means they oxidize, they undergo oxidation easily. So zinc is good reducing agent than iron. Similarly, oxidizing ability, what happens? Increases along the series. Metals with more positive or less negative potentials act as strong oxidizing agents. That means they undergo reduction easily. So Ag is good oxidizing agent than copper. And the metals placed above in the series displace the lower metals from their source. So whichever metal is placed above, that is added to some solution which is below, so that will be displaced because it is more reactive. So when Zn is added to CuSO4 solution, then this Cu is replaced and Zn will be displaced here. Okay, then next. The metals placed above hydrogen in the series liberates hydrogen gas from acids. So whichever the metals above hydrogen, those will be added to the acids and it liberates hydrogen gas and corresponding salt will be formed. The metals placed above hydrogen in the series undergoes corrosion easily. So whatever the metals placed above hydrogen, they undergoes corrosion easily. Why they undergoes corrosion easily? Because they are active metals. So this is our electrochemical series. So what is electromotive force? So in the last class only I told the difference in electrode potentials causing the flow of electricity from higher electrode potential to the lower electrode potential. It is given by the formula E cathode minus E anode, E right minus E left. So if you know the formula and if you identify the which is anode, which is cathode, then you can do the problem very fast. Okay, so now the next we studied the problems on EMF. So cell representation and which is undergoing reduction, which is undergoing oxidation. So what are the, so during calculation of E cell, so you have to take the SRP values, okay, standard reduction potentials. Only you have to take, if at all they will give oxidation potential, you have to convert into SRP values. So what conversion is just, you have to change the sign. So SRP is equal to minus SOP. If it is plus, it will become minus. If it is minus, it will become plus. Okay. So then battery topic is very important. So compulsory you get two cells, that is either dry cell, either lead storage cell, either nickel cadmium cell. Okay. So in the next class we'll study the fuel cell. So during that class also once again I will repeat all these cells and then I will go for next cell. So if you have any doubts, you can clarify your doubts. Okay. So here one thing you have to remember, oxidation reduction. At anode oxidation, at cathode reduction. Okay. So always at anode oxidation, always at cathode reduction. What is oxidation? What is reduction? Oxidation means losing of electron, reduction means gaining of electron. So how to write those equations? If you know this, you can write the equations easily. So practice equations, then only you can write equations in the exam perfectly. So by seeing the notes you can't write the equations, you have to practice the equations. Okay, thank you students.